Welcome back. This video is about testing ACF and PACF tests in R. So in time series econometrics, there is a very powerful and important technique called Box-Jenkins method, which uh, is used to estimate and forecast the time series. However, there is while doing this, if you don't know what the data generating process is, whether it is following a AR process or MA process or AR-MA process, then doing the forecasting by using different data generating process would give you different results. So before going for any before going to use this ARMA process to forecast or estimate any time series econometric model, so what we have to do generally to test whether the data is following a AR model or MA model and MA process, sorry. So and to check that, we have we have to do this ACF autocorrelation function and partial autocorrelation function test, and in R there is it is very simple. So there is two function are called ACF and PACF is already there in the R. No need to install any package for that. You need to supply the data and find out and give specify also how many lakhs you want to take, like up to how many lakhs you have to you are checking that whether the that ACA function is the ACA function, and up to what lakh the PACA function you have to specify that, and it is really simple. So what I am doing today is I'm taking an example from Walter Ender's econometrics, time series econometrics book, where Enders check for the ACF and PACF function of the interest rate spread. So interest rate spread is basically the difference between the interest rate of 10-year bond, US bond, and the treasury 3 months treasury bill. So that the difference between these two variables in interest rate is called the interest rate spread. So before I have that data here, which is a quarterly data. So what I have to do, I have to since I have that in Excel for format, so I am importing the data. So I have to call all this library, and this is not required for the time being, and however chew is required. So this package is mostly for all the very important package for any kind of time series analysis. So and most of the packages are built up on this one. So I'll call these three packages. Now it is there. Now I'll call my data, which I am, this is the data. I call it, okay, I call it now you'll see there is 19 variables and 212 observations. So I'm renaming the data into in a new data called this thing. Then I'm defining the date, because in R will not automatically read the data as a quarterly data or quarterly data, annual data, or monthly data. For that you have to define the date into the whether it is a quarterly or monthly or annual data. For that, this chew package is essential. So this is the way I'm defining. You can define the data. So as a quarterly, this since it is quarterly, I'm defining it is as quarterly. Now it is done. So I have to construct a new variable, which I mentioned earlier, is the interest rate spread, which is the difference between the interest rate of 10-year US bond and 3-month US Treasury bill. So I computed that if you open, if you'll see that there will be a new variable called spread will be created. So first of all, before going for any analysis, we have to see what the data looks like. So what I am doing here in this function, in this command, this line of command, I am plotting the this spread. I am plotting the spread data. So if I'll plot it, this is what it is saying. This is in actual term. What is saying that there is a if you can observe, there is a persistency in the data, which is like if it is following a upward trend, it is following a upward trend. If there is a downward trend, there is a downward trend. So it is very essential for any kind of because any kind of time series analysis, because here you can see the data contains a lot of information. Now on the contrary, if I difference the data, so I'll just put a line here. So you can see that only only at 2-3 points there is this series is becoming negative, and there is no structural wave break, since there is no shift in the mean and variance of the drastic shift in the mean and variance of the data. It is the data is covariance stationary. So and if on the contrary, if I'll and as I told, this contains a lot of information. So as I on the contrary, if I'll plot the difference of the data, so this will look like the, there is it's pretty erratic in nature. So it is better to use the actual data and to check for the ACF and PACF function. So if to check for the ACF function, first I'll do the ACF test, then I'll go for the PACF test. For to do the ACF test and find out the plot of the ACF test, you have to use this function ACF, then data, which is our data set name, and then the variable name for the variable for which you are doing the ACF. Then we are taking the up to maximum 12 lag, we are checking the ACF and this is only the like how much interval in the y axis. For that you are giving, I'm giving 0.02, you can give any range. So if I do that, what it is saying is that your ACF function, these are the lags. Okay, you can see these are the lags, and this is your ACF, this is the lag. Then there is 12 lags, and at lag 1 up to lag 8 it is declining, the ACF function is declining, and again after lag 9 it is becoming negative. So the criteria to decide whether a series is a autoregressive of order 1 is that the ACF function should decline eventually after first lag, and uh, and for the MA1 there is a the series, the ACF, the series ACF series, it should completely after the first lag, if you want to say that it is a MA1 process, there should be no other spikes. So if you see that it is neither it is following neither it is a MA process nor it is a AR process. So and if you see the PACF, if you see the PACF function, it is, if you see the PACF function, it is also same. It is following a oscillating pattern that at lag 1 it is pretty high, 0.89, then it decline, then up in lag 2 it is negative 0.02, and up to lag 6 7 it is this function is saying that it is the series is not at all a AR process. So if both the ACF and PACF test is rejecting that this series is not either AR process or MA process, then how to find out that at what lag this function, whether it is a AR2 process or AR3 process or AR7 process, how to do that. So in maybe in the next video I'll see, like I'll try to do that. So and doing the ACF and PSCF test is uh, easy, as Enders point out in his book that it depends on the judgment of the uh, person who is doing, or the econometrician who is doing, to find out which order of AR or MA the data is. So this is for today's video. Thank you very much for watching.